Hello, welcome back to the LOOC. In this last segment on exceptions, we are going to look at user-defined exceptions. In some cases, there are situations when a problem occurs that's specific to a particular program, so it doesn't fit in the types that are provided in the .NET framework. And that's when programmers can create user-defined exception classes. They should be derived from the exception class of namespace systems, and they should be well documented. One guideline that Microsoft provides in this respect is that when a new user-defined exception class is defined, it should have three constructors. A parameterless constructor that has no parameters, it's kind of like a default null constructor. A constructor that receives a string argument, that is an error message, and a constructor that receives a string argument, the error message, and an exception argument, the exception argument being the inner exception object. And we should create exceptions only if the .NET Framework class library doesn't contain one. So in our next program we see an example of this, the negative number exception, which is created to represent a situation when a program tries to perform the illegal operation of taking the square root of a negative number. So here is the code. Again, there is no predefined negative number exception in the .NET class framework library, so the programmer defines a new class for it. It doesn't have much code in it. It in reality just creates three constructors. One that takes no parameters, a default constructor, it's called negative number exception, and it makes an explicit call to the base class. Exception is a constructor and passing the error message, which is illegal operation for a negative number. So note that the negative number exception class is derived from the exception class of the system namespace. And it basically has an empty body. The second constructor is one with a single string argument, message value, and again it invokes the base class exception constructor explicitly, passing in the single string argument, and again has an empty body. And finally the third constructor, which has a message value and an exception object for the inner exception, which is then again, which are again passed to the base class exceptions constructor, explicit call to the base constructor, the message value and the inner exception object are passed in, and again has an empty body. That's all that is needed for the user-defined exceptions, and the actual message will be provided in the constructor when we need to throw this exception. So here is a program called square root test with the main function in it. As before, we have a continue loop boolean sentinel variable set to true, and a do-while loop that keeps looping until the user corrected the error. So the main part of the do-while loop is a try block in which we prompt the user to enter a value to take the square root of, and we attempt to call the square root function to get the result. However, this can throw an error. But assuming that it does not, then we display the error and set the continue loop false, assuming everything went correct. Otherwise, we have two catch clauses. One is a format exception that is familiar already from the divide by zero case, when the string the user typed in does not convert to a number, and the negative number exception case. This is the user-defined exception class, negative number exception, and again we write a catch block for this one too, so in both cases we inform the user of the error and ask that they enter the values again. That's the end of the while loop, and it keeps looping like this until the user enters a correct value. That is a non-negative number. Here is the square root method that can throw the error. So it takes a double value, and if it's negative, then it throws a negative number exception. The keywords are true and new, because we are creating a new exception object with the constructor negative number exception, and this is where we put in the actual message that informs the users of the error. So square root of a negative number is not permitted, and this message string will be then the message string of the as here in the second constructor that constructs it with a single message string, and that will be constructed in the square root method. That's what we'll throw. Otherwise, we perform the actual square root command. The math sqrt function will work. So that's at the end of the program, and here are three possible outputs. First, we enter the number 30, and we correctly compute its square root. Then next, a format exception happens. We enter something like the string hello that is not cannot be converted to a number, and the exception is thrown, and we handle it. So the message please enter a double value it comes from the catch block, the handler, and then the loop loops back to asking the user again to ask for a number whose square root can be computed, like 25. In the third case, we enter a negative number. Unlike the previous case, hello, for which there was a predefined exception class, the format exception, now we have the situation for which there is not a predefined exception class, so we defined one, the negative number exception. So when the user enters -2, then the square root method throws the negative number exception with the message square root of negative number not permitted. Please enter a non-negative value, and the program loops back again to the input part, and if this time the user enters a correct input, then it calculates the square root correctly. So if we go to this program to see it running, then we are going to see the classes. So one of them is the negative number exception class, which is right here, took a little while to open up. So it is derived, like all user-defined exception classes should be derived from the exception base class, and should have three constructors. One, a default constructor which does not have any argument, with an explicit call to the base class constructor passing in a message value, because the base class has a single string parameter constructor, and our constructor is an empty body. The second constructor, one that can specify, customize an error message, so a single message value string passed in, call is made to the base class exceptions constructor, and again an empty body. And the third one is the two parameter constructor, negative number exception with a string and an inner exception object, again explicit call to the base class constructor and empty body. And that's all there is needed to create a user-defined, programmer-defined exception class. And if we go to the test program, then we see the main method and the do-while loop that keeps looping as long as the continue loop boolean variable is true. It gets negative when the try block is successful. Within the try block we ask for the user input, the number to compute the square root of, and we call the square root method to do so, which we wrote, which however has the ability to throw a negative number exception. If it doesn't and everything goes correctly, then we display the result as a 6-digit floating point number, and we set continue loop to false, which will terminate the loop. However, if in the try block the square root method does throw an exception, then it can be one of two kinds: either a format exception, in which case we inform the user and give prompt to enter a double value, and with that the while will resume the try block again. And the other case is the negative number exception, in which case again we inform the user and prompt the user to enter a non-negative value, and the while will again loop back to the input. And this keeps going on until a correct value is entered. The actual method, square root public static double, takes a double argument. It checks validity. If the value is negative, then it throws a negative number exception. Throw new negative number exception. This is a constructor call, and we are making a call to the single message string constructor with the message square root of negative number not permitted. Else, if there's no error, then we call the math object square root function and compute the square root. So if we now compile and run the program, then we should see the result. So it takes a few seconds to complete. And then we can run it. So with Ctrl F5 the program runs and the output appears. So enter a value to calculate the square root. So if nothing is wrong, I enter a number like 30. then it calculates the square root and displays it. There was no error in this run. Let me run it with Ctrl F5 again. So suppose this time I am making a mistake by entering something, string hello, that is cannot be converted to a double number. So the format exception was thrown, hence the message, and please enter a double value is what we added as error handling in the catch block, and the loop relooped into taking the input again. So if this time I enter a correct value, then it will compute its square root correctly. So this was a format exception case. And finally, if I run the program again, and this time enter a negative number like -2. Suppose I wanted to enter 2, but by mistake entered -2. Then here it is. We throw a negative number exception type exception object with the message square root of negative number not permitted. The catch block as a way of exception handling outputs the message please enter a non-negative value, and the loop loops back to the input again, and this time I can realize that I really wanted 2, not -2, and then the program correctly completes without crashing, of course, without a runtime error, because we are handling all the exceptions that can happen, which in this case 2, a format exception or our user-defined negative number exception. And once we correct those, the program continues without breaking, without any runtime error. So that was the user-defined exception class, and that completes this segment.